Assalamu alaikum. Well, children, we have yesterday in the previous period we started in the previous video rather we started the second exercise wherein we learned how to multiply. At the first stage we learned how to multiply expression with one term, monomial, by another monomial. To recollect the procedure, you were told there is no restriction of like terms and unlike terms in case of multiplication and division. We can multiply any expression having one term, monomial, by expression with one term. Then, as we multiply them, you have seen yesterday, we multiply coefficient part by coefficient part. Coefficient of first monomial by coefficient of second monomial. And then variable part of first monomial we multiply by the variable part of second monomial. While multiplying those variable parts, you were told yesterday, you have to use law of multiplication when bases are same, powers are added. We'll have more practice of this in the next questions of this exercise. You have question 3, question 4, question 5. Question 3, you have a table given on your textbook. This table shows you again which monomials you have to multiply. In the first slot, you find two statements written. First monomial is written, second monomial is written, and then in front of the first monomial, you have different columns. Values of first polynomial in different cases are given there: 2x, minus 5y, 3x square, and so on. And second monomials, pointer is shown downwards, therefore the values of second monomial are given downwards. The first value is again 2x, followed by minus 5y, 3x square, minus 4xy, and so on. So therefore, while completing this table, you have to use different first monomial and corresponding second monomial. Like when you consider the first case, it is like this. Horizontally you are given first monomials. The first value here is 2x, followed by minus 5y, and so on. Downwards you are given second monomial. The first value is 2x, followed by again minus 5y, and so on. You have to multiply them. How will you understand that you have to multiply them? You can see on the top the statement written, complete the table of products. Products means multiply. You have to multiply them. Now which slot will consist of which first monomial and which second monomial? For example, if we choose this slot, to fill in this slot, you have to multiply the first polynomial for this product will be the one which is exactly above this. Look at the monomial written above this on the top, it is 2x. So this 2x you have to use as first monomial. And in line with this, on the left side, you will find second expression written. It is here in line with this minus 5y. Means this 2x you have to multiply by the 2x on the top in line with this slot I have chosen. It is 2x. It is multiplied by minus 5y. Second polynomial, second monomial is minus 5y. And then you were told yesterday that if you have two signs together, like multiplication and minus sign we have together here, in such a case we use bracket. So it is 2x multiplied by minus 5y. Minus 5y is put in the bracket. You will do this multiplication as you did yesterday. You have to first multiply coefficient by coefficient. Coefficient here is 2, coefficient here is minus 5. The product will be minus 10. 2 5s are 10, plus minus is minus. So the product is minus 10. Then you have to multiply variable parts also. The variable part in the first monomial is x. That does not appear in the second monomial. So yesterday I told if you want to introduce that, though there is no need, if you want to introduce, you can write that, but the power of that x will be 0 there, because it does not exist there. Then that x, this x will be multiplied by x raised to power 0. Here we use the law in multiplication. Bases are same, powers are added. This power is 1, this power is 0, sum will be 1. So it will be x raised to power 1. Likewise, here the variable part is y. But y does not appear in the first polynomial. And the procedure will be same. If you want to introduce that y in the first polynomial also, you will have to write that again. Instead of x raised to power 0, now y raised to power 0. And then you have to multiply y raised to power 0 by y. Same law will again be used in multiplication. Bases are same, powers are added. It will be y raised to power 0 plus 1 will be 1. The product therefore is minus 10xy, and this minus 10xy you will then write in the slot here that we had earlier chosen. Minus 10xy. It is the product of 2x and minus 5y. Now similarly you have to fill in the different slots by considering first monomial in line with that slot. Suppose this slot we choose. Now what will be the first polynomial here, first monomial here in line with this? Among the first monomials we have 2x. So first monomial will be again 2x. It is to be multiplied by second monomial. Again you have to choose in line with this slot that we have chosen. And the second monomial here is 2x again. So this time you have to multiply 2x by 2x. Now how will we multiply? Coefficients first will be multiplied. 2 2s are will be 4. Then variable parts will be multiplied. Bases are same, powers are added, law is used. It is x square. So the product here is 4x square. We'll write in this slot then 4x square. Two of the slots I have filled. I have shown you how to choose the first monomial, how to choose the second monomial, and then multiplication is same as we did yesterday. I shall leave this filling of this table for you. Try these and let me know on the WhatsApp if any of the parts you fail to understand. We'll do that. Now the practice of multiplying monomial by monomials will continue. So far in the 3 questions we have discussed, we had to multiply one monomial by one monomial only. Now we'll come across questions. Question number 4 and 5th will be based on multiplying 3 or even more than 3 monomials. We'll have one monomial, second monomial, third monomial. We have to multiply those monomials again. Now the procedure will again be same. Out of the 3 monomials, you will first multiply 2, like we did here. Then the product of the 2 will multiply then by the third monomial. Let us consider examples. Statement is here. Obtain the volume. Earlier we solved one question where we had to find area of rectangle. We used the formula for area of rectangle, length into breadth. Now you are asked to find volume. Volume of rectangular boxes we call cuboids. Rectangular boxes we call cuboids. Volumes we have to find with the following length, breadth and height. First part. It is question 4, part 1. The dimensions are 5a, 3a square 7a raised to power 4. So these monomials, 5a monomial, 3a square monomial, 7a raised to power 4 monomial, these are our length, breadth and height of that box. Volume we have to find. So length of box is equal to 5a. Breadth of box is equal to 3a square. Height of box is 7a raised to power 4. Volume we have to find. Volume of box we have to find. To find the volume of box, we'll use the formula of volume of cuboid. Box, rectangular box is called a cuboid. The formula of volume of cuboid, you know. Use that formula. Volume of cuboid, here it is box, volume of box will write, is equal to length into breadth into height. Length into breadth into height is the formula for volume of box, volume of cuboid. So what we'll do, for length we'll write 5a, for breadth we'll write 3a square, for height we'll write 7a raised to power 4. And then multiply them. Procedure is same. Since we have 3 monomials to be multiplied, to make things simple, we'll first choose out of 3, 2 only and multiply them. Third one will keep same for the time being. Let us choose first and second. Multiply these. Now the procedure is, we'll first multiply their coefficients. What is the coefficient here? 5. Here it is 3. Multiply them. 5 3s are 15. And then multiply the variable part of these two monomials. A square, bases are same in multiplication. Powers are added. What is the power of this a? Nothing is there, so 1. Power of this a is 2. Add them. 1 plus 2 will be 3. It is a raised to power 3 therefore. The third monomial we will keep same. 7a raised to power 4. In this way, we have changed the 3 monomials to now only 2 monomials by multiplying the first 2 monomials first. Now we have the product of 2 monomials only. 15a cube, 7a raised to power 4. To multiply them, again same procedure will be used. Coefficients will be first multiplied. 15 7s is 105. 15 7s. Then multiply variable parts. Again use the law. Bases are same, powers are added. We'll have a raised to power 3 plus 4 will be 7. Bases are same, powers are added. 3 plus 4, 7. This 105 a raised to power 7 therefore is the volume of this box, which has length as 5a, breadth as 3a square, height as 7a raised to power 4. Same procedure we have to use in the remaining parts of this question also. Let us now consider part number 2. Fourth question, second part. This time the dimensions are 2p, 4q, 8r. These are the dimensions now. Now as per the statement, word respectively is there. 2p will be the length of the box, 4q will be the breadth of the box, 8r will be the height of the box. So write against length 2p, against breadth 4q, against height 8r. We are not doing anything new, just dimensions we are changing as per the question. Length is given, breadth is given, height is given, volume you have to find. Now to find that volume, use again the formula. Volume of box is length into breadth into height. To find the volume, put the values of these. Length is 2p. It is multiplied by breadth is 4q. It is multiplied by height is 8r. What shall we do? Just now we discussed. We'll first multiply first monomial and second monomial. Third will keep the same for the time being. How to multiply these two? First choose their coefficients. 2 is the coefficient, 4 is the coefficient. 2 4s are is 8. So 8 is the coefficient here, product of 2 and 4. Now multiply their variable parts. The variable part here is P, the variable part here is Q. Since we don't have same basis, therefore that law cannot be applied. You were explained, you were told in earlier parts, you can introduce this P in this second monomial also. Likewise, that Q of the second monomial we can introduce in the first one also. But it is not necessary, you will always do that. That was just for making things simple, to make you understand. Now, in such a case, we keep the first monomial, variable of the first monomial also same, second one also same. So P will remain as P because we don't have that P in the second monomial. Q also will remain as Q because that Q is not in the first monomial. Therefore, the product of these two is 2 4s are 8 PQ. Variable parts are directly multiplied because we don't have that. We don't have to use that law of multiplication. That is applied only when bases are same. Then only we add powers. Here we don't have same bases. P base, here Q base, they are different. The third monomial 8R we shall keep same. And then in the next step, now we will multiply these two monomials. 8PQ is the first monomial now, 8R is the second monomial, multiply them, procedure will be same. Coefficient by coefficient, 8 8R will be 64. This is the coefficient. Now multiply variable parts, and again the same situation we have. We have the variable P here. We don't have the variable P in the second. Therefore P will remain same. Had P been there also, then we would use the law in multiplication, bases are same, powers are added. We don't have, so it will remain same. Similarly, Q in the first monomial does not appear in the second. The product therefore will contain Q again as it is. Then in the second monomial, the variable R does not appear in the first. Therefore, same procedure, this R will also remain same. The volume of the cuboid, therefore, volume of the box, therefore, is 64 PQR. This is the procedure you have to use in the parts. Let us do part number 3 also. Here is part number 3 now. Part number 3 of 4th question. XY is the first monomial. 2x square y is the second monomial. And 2xy square is the third monomial. Now, as per the statement, the first monomial you have to use as length. So length of the box is xy. Second monomial you have to use as breadth. So breadth is 2x square y. Third monomial you have to use as height of box. Height is therefore 2xy square. These are the dimensions. Volume we have to find, so the question mark is here, and then we use the formula. Volume of box is length into breadth into height. Put the values of length, breadth and height. Xy as length multiplied by 2x square y as breadth multiplied by 2xy square as height. 3 monomials are there. Multiply. Now, for the sake of convenience, we'll again choose out of the 3, first 2 only. The first 2. First one xy, second one 2x square y. We'll keep this third as it is. Let us first multiply these two. And when you multiply these, first what will you multiply? Coefficients of the two. What is the coefficient here? It is 1. Nothing is written, so 1. Here it is 2. The product of these two coefficients will be 2 1s are 2. We multiplied their coefficients. Now variable parts will be multiplied. And in the variable part, we find the first variable is x. which appears in the second monomial also. Therefore, the law will be used in multiplication. Bases are same. Powers will be added. Power here is 1. Nothing is there. 1 is there. 2. 1 plus 2 will be 3. So it will be 2x raised to power 3. Then similarly, y will be raised to power 2. Y variable also appears in both the monomials. So use of law will be there. Bases are same. Powers are added. What do we have the power here? 1. Here also 1. 1 plus 1 becomes 2. This is the product of the first two monomials. Now this product we have to multiply by the third monomial, 2xy square. What will we get? Coefficients when multiplied will give you 4. 2 2s are 4. Multiply variable parts, and in the variable parts you have to first multiply x's, base x. Powers will be added. You'll get x raised to power 3 plus 1, 4. Power here is 3, power here is 1 in case of x variable. 1 is the power. 3 plus 1 becomes 4. What about y? Y also will be raised to power 4. 2 plus 2, 4. This is therefore the volume of that box. 4 x raised to power 4 into y raised to power 4. That was part number 3. Then the last part of this question also I shall leave for you. You will try this and accordingly let me know on the WhatsApp. Now 5th question. That is the last question of this exercise. Question number 5. Procedure will be same. We are again asked to obtain the product of multiply. We have to perform. First part, 3 monomials are again involved. xy is the first monomial, then comma, yz second monomial, and again comma, zx is the third monomial. We have to multiply these. Commas are written between the monomials here. So in the first step, what shall we do to begin with? We'll replace comma by multiplication sign. It is xy multiplied by yz multiplied by zx. This is our question. Just now we have learned while finding those volumes how to do it. Out of the 3 monomials, let us first choose 2. These 2 let us again choose. xy, yz. Let us multiply them. And as seen there, we first multiply their coefficients. Coefficient is 1. Coefficient is 1 because nothing is there. The product of 1 and 1 is again 1. And we need not write. 1 is understood always. So we need to multiply their variable parts. The first variable part here is x. That x does not appear in the second monomial. You can introduce that as I have already said. X is power 0. Or, no need of introducing. In such a case, the variable part x will remain same because it is not multiplied by anything. X remains same because that x does not appear here in the second monomial. Then comes the turn of multiplying y variable, and we have y variable in both the monomials. First monomial, second monomial, both have y. Therefore the law will be used in multiplication. Bases are same, powers are added. We'll get y raised to power. The power here is 1. The power here also is 1. 1 plus 1 will be 2. X, y raised to power 2. Then comes the turn of z variable, which is in the second monomial. First monomial does not have. Remember, we are multiplying first and second monomial. Third, we are not multiplying right now. We'll keep that same. In the first 2 monomials, z is only in the second. Since it does not appear in the first, so it will remain same. X, y square, z is the product of first 2 monomials. This monomial thus got will be then multiplied by the third monomial zx. What will we get? Now again we have to multiply 2 monomials. This is our now first monomial, x, y square, z, which we got as the product of these 2. Second monomial is zx. So the rule is same. Coefficient will be multiplied by coefficient. 1 by 1. 1 ones are 1 and 1 we need not write. Now multiply their variable parts, and the first variable here is x. X is in the second monomial also. So therefore when we multiply, we'll use the law. Bases are same, powers are added. It will be x square. First variable. Second variable y square does not appear in the second one. So therefore we need not multiply. Y square, y does not appear in the second. So therefore y square will remain same. Or as already explained, if you want to have that y in the second one also, second monomial also, you will write y raised power 0 there. We have already read anything raised power 0 is 1, so therefore that will not change the value. And then we can use the law to get y raised power 2. Since it remains the same, y raised power 2, y raised power 2 was here also in the first polynomial. That is why we conclude in such a case that it does not change, it remains same. What will happen to z? Z appears in both the monomials. Therefore law will be used. Bases are same, powers are added. 1 plus 1 will be 2. So it will be z square. That is the product of first part. Coming to second part, we again have three monomials. The first one is a, second one is minus a square, third one is a raised to power 3, a cube. Let us multiply these. Now to multiply these, let us replace commas by minus signs, multiplication signs. They are multiplying, we have to find product. So this is what we get. This comma as well as this comma, we have to replace it by multiplication. And then as earlier said, wherever there are two signs together, use bracket. Therefore this minus a square will put in the bracket. This has already been explained. Three monomials to be multiplied again like the previous part and the parts of the previous question. How will we do? We'll first choose 2 and multiply them. Then the product got will be multiplied by the third. Let us multiply these two first. What will we first multiply? Their coefficients. 1, minus 1. This is 1 here, the coefficient of first monomial. Minus 1 is the coefficient of second monomial. When we multiply them, it will be minus 1. So I wrote minus only. 1 I did not write because 1 is understood. Minus 1 is actually the product. Even if we write, that will not make any difference. Now, having multiplied the coefficients, now multiply the variable parts. We have a square. Here bases are same. Powers will be added. We will get a cube. Therefore 1 plus 2. Power of this a is 1. Power of this a is 2. 1 plus 2, 3 as per law. This is the product of the first two monomials. And this product of the first two will then be multiplied by the third monomial. And when we look at this, it is again the product of two monomials now. So the same procedure will be applied. Coefficient minus 1, coefficient plus 1, product will be minus 1. I wrote this one here. But there is no need of writing this because 1 is understood, so better not writing. I rubbed it. This is minus. Minus plus is minus. Now multiply their variable parts. Again we find a appears in both of these. Therefore law will be used. Bases are same. Powers are added. We'll get a raised to power 3 plus 3 will be 6. Therefore the answer of the second part is minus a raised to power 6. Coming to third part. In the third part now you have 4 monomials. Third part involves 4 monomials. The first one is 2 followed by comma, 4y, 8y square, and the last one is 16y cube. These 4 monomials we have to multiply. So we'll begin likewise. We'll replace first commas by multiplication sign. There were 3 commas, so 3 multiplication signs we got. Each of these expressions is a monomial that we have to multiply. So what will we do? How will we do? Procedure will be same. Steps will increase now because number of terms, number of monomials is more. Steps will increase. We'll multiply first 2 monomials first. Means 2 and 4y. Keeping these two same. It will be 8y here. 2 4s are 8. Y is the variable part. And the first monomial y does not appear. So it will be y raised to 0 there. Then bases are same. Powers are added. Multiplied by 8y square multiplied by 16y cube. Third monomial, fourth monomial unchanged. We multiplied in the first step only first 2 monomials. Now this has 3 monomials. So it has become now the previous question. Out of the 3 monomials, again we'll multiply first 2. 8y is the first one. 8y square is the second one. Let us multiply these. 8 8s will be 64. Coefficient by coefficient. 8 by 8. Variables, when you multiply, we get y cube. Powers are added. 1 plus 2 into 16y cube. Then finally multiply these 2 monomials. 64 coefficient, 16 coefficient will be multiplied. Variable part y cube will be multiplied. Bases are same, powers are added. Law will be used. Let us first multiply the coefficients. 64 by 16. The product will be 1024. This is the coefficient now. Variable parts, when bases are same, powers are added, law will be used. It will be 3 plus 3, 6. So the answer is 1024 y raised to power 6. That was part number 3. Fourth part I shall leave for you all again. Try this and let me know. Now let us do the last part, fifth part. With that, this exercise will come to end. Fifth part. M is the first monomial, comma, minus mn is the second monomial, then again comma, mnp is the third monomial. So replace commas by multiplication sign. Then as already said, again we have 2 signs together here. We'll use bracket. And then out of the 3 monomials, choose the first 2 monomials, multiply first them. Then the product will be multiplied by the third. As we multiply the first 2 monomials, coefficients will be first multiplied. 1 is the coefficient, minus 1 is the coefficient. So the product will be minus 1. Sign alone is written, minus sign, 1 is understood. Multiply their variable parts. M is the variable. Bases are same, powers are added. M square. Second variable in the variable part of second monomial, n does not appear in the first monomial. Therefore, that n will remain same. This product is then multiplied by the third monomial, m and p. What will we get? Same procedure. Coefficients will be first multiplied. It will be minus 1, so minus alone is written. No need of writing 1, which is understood. Multiply their variable parts. M square will be multiplied by m. It will be m cube. Powers are added. N and n will be multiplied. It will be n square. Powers are added. 1 plus 1. P will remain as it is because that p is only in the second monomial here. First one does not have. The product therefore is minus m cube n square p. That was the last part of this, and let us conclude it here today.